Lesson 1.5, Day 2, Properties of Exponents. Please write down the essential question. How can I simplify expressions with scientific notation? So scientific notation is a method of writing numbers by using powers of 10. In scientific notation, a number takes a form m times 10 to the nth, where m is any number that is greater than or equal to 1 and less than 10, and n is an integer. So I'm going to write some examples down. And, all right, let's change. So if I have 1.275 times 10 to the 7th, so you should also be writing this down. I'm just writing an example of something written in scientific notation. And now we're going to write it in standard form. Because the exponent is positive, that's telling me that when we go write it in standard form, we are going to move the exponent, not the exponent, the decimal to the right. So 1.275, I'm going to move it to the right 7 places. 1, 2, 3, 4, 5, 6, 7. And all these little hoops, I fill in zeros. So what does that lead us to? That leads us to 12,750,000. So let's try another number in scientific notation, 3.5 times 10 to the negative 3. Because the exponent is negative, that tells us that we have to move the decimal place to the left, going from scientific to standard form. So 3.5, I'm going to move it to the left 3 places. 1, 2, 3. There's my decimal. So that equates to 0.0035. Now we're going to go the other way. So we're going to start in standard form. And if I have 1, 3, 2, 5. My decimal place is over here. If I'm going to write in scientific notation, and the key to understanding this, scientific notation means the decimal is 1 after the first number. So to go from standard to scientific, I have to move the decimal, which in standard form is out here, 3 places. 1, 2, 3. 3 places to the left. So 1.325 times 10 to the third. Because remember, up here when we were going from scientific to standard, if I was flipping it here, scientific to standard, I'd be moving the decimal place to the right, just like we did up here. But now I'm going the other direction. So let's say we have the number 0.00046 and I want scientific notation. Scientific notation means I need the decimal place after the 4. So 1, 2, 3, 4. So that's going to be 4.6 times 10 to the negative 4. So there we did a couple of examples going from scientific to standard and standard to scientific. The key is with scientific, the decimal has to be 1 after the first number. So now we're going to write a little note here, and you should be writing this down too. When we have a negative exponent, when written in scientific notation, that means we are dealing with a small number. And when we are dealing with a positive exponent, oops. All right, there we go. A positive exponent, that means we're dealing with a big number. This marker is not working very good here today. Big number. All right, so negative exponent, small number, positive exponent means big number. All right, example 1. We have a number written in scientific notation divided by another number written in scientific notation. When we do that, what we do is we first of all divide 4.5 divided by 3.5. On our calculator, that is 3. But scientific notation means we can't just write 3, we have to write 3.0. Times 10, okay, we're dividing. Remember, when we divide, we subtract the exponents. So negative 5 minus 6 is a negative 11. And there's our answer. Multiplying, I'm going to multiply 2.6 times 8.5. That is 22.1. When we multiply, we're adding the exponents. So 4 plus 7 is 11. But this is not in scientific notation because the decimal has to be moved one place to the left. So when we move it one place to the left, we get 2.21. We went from a bigger number to a smaller number, which means that the 11 is going to go to a 12. So these are opposites of each other. If the number over here, 22.1, goes from bigger to smaller, then the exponent goes from smaller to bigger. And there's our final answer. All right, example 2. So again, we're dividing. So when you divide 2.325 divided by 9.3, you get 0.25. When we divide, that means we're subtracting the exponents. 6 minus 9 is negative 3. Again, this is not in scientific notation. We need to move the decimal one place to the left, or excuse me, to the right. When we do that, we get 2.5. So we went from a smaller number to a bigger number. So that means we're going to go from bigger to smaller. And on both of these, I'm going to go back. We said bigger to smaller. We moved the decimal one place to the left. And here the exponent went from smaller to bigger. We just added 1 onto the 11. And here the same thing. We went from a smaller number. Hold on. Okay. We went from a smaller number to a bigger number by moving the decimal one place to the right. So therefore, we're going to go from bigger to smaller. And what we're going to do is subtract 1. If we would have had to move the decimal more than one place, let's say 2 places, then we would have subtracted 2. We're going to do this example in class. And now I'm going to have you pause the video and answer the video questions in your notes.